Okay, let me share my screen. All right. All right, greetings, YouTube. Beautiful mind here. Hope you all had a great weekend. No real announcements. You know, this is the top of week 10, right? So week 12, we can anticipate exam 3. We're rapidly approaching the home stretch, right? Sorry about that. So, you know, we have exam 3. I think after exam 3, we might have like maybe one more section. Then we're going to have like Thanksgiving break. Once we have Thanksgiving break, we're essentially done because, you know, we'll have that Wednesday, I think probably that Wednesday, Thursday, and Friday off. We'll come back, I think, for a couple of days, and then we'll have the reading period, and then it'll be finals. So that'll be here, you know, quick, fast, and in a hurry. But otherwise, let's just kind of go ahead and kind of press forward. As usual, this is remote asynchronous. And, you know, if you have questions, the best way is to just unmute yourself and get my attention and we can stop and talk about it. Or feel free to use the chat. I do check the chat periodically. And again, I'll check attendance for anybody that's coming late at around the 15-minute mark. So today we're continuing chapter 6 with further topics in algebra with section 6.2, arithmetic sequences and partial sums. And a few objectives here. We like to identify an arithmetic sequence and find its common difference. And we like to find the sum of the first n terms of an arithmetic sequence. So we have the definition of an arithmetic sequence. Now, like last time, I know we kind of did an introduction to sequences. And I know we looked at arithmetic sequences and geometric sequences, all right? So arithmetic was where, you know, we have a common difference. We're adding the same thing each step. You know, we might add a positive or we might add a negative, but we're adding the same thing at each step. So that was arithmetic. And then geometric would be where we're multiplying the same thing at each step, right? So that's what this should be about, right? So the definition of an arithmetic sequence. So this sequence given is an arithmetic sequence or an arithmetic progression if there's a number d such that each term in the sequence except the first is obtained from the preceding term by adding d to it. The number d is called the common difference of the arithmetic sequence. And so we have the common difference is going to be the a sub n plus first term minus the a nth term, as long as n is greater than or equal to 1, right? So this is just telling us how to find the common difference. You just take one term minus the term before it, okay? All right, so that's a more formal presentation for arithmetic sequence, but it's essentially the same thing that we talked about last time. So then here we're asked to find the common difference of each sequence. Give me just a moment. Ooh. Right, so if they're telling us that it's arithmetic, then that means that there should be a common difference, right? We should be adding the same thing at each step. So, you know, we can verify. For instance, like if we're starting with part A, notice that 23 minus 3 is 20. Okay. 43 minus 23 is also 20. Yada, yada, yada. So the common difference, so it looks like the common difference is 20. And I think that's it for that one. Because that's all the instructions asked us to do. Okay. Copy. Okay. All right. And then for part B, so if we say 19 minus 29, I think that difference is negative 10. If we say 9 minus 19, still negative 10. So we're adding negative 10 each time. So our common difference is negative 10. Okay. I feel like these are okay. So we got 20 and negative 10. So for part A, you see the 20 there. And then for part B, you see the negative 10. Okay. So let's keep going to see how this goes. So now we've kind of introduced arithmetic sequence, right? Or arithmetic progression where we're adding the same thing each time. So then we kind of touched on this last time as well, the recursive definition of an arithmetic sequence. So the recursive definition is going to be like, basically it feeds back on itself, right? So our arithmetic sequence, so this is arithmetic meaning that we're adding, we have a common difference, we're adding the same thing at each step, can be defined recursively. So the recursive formula is that the an plus first term is going to be the nth term plus the common difference, as long as n is greater than or equal to 1. Right? So for instance, if you want the second term, it's going to be the first term plus the common difference, so on and so on and so on. This defines an arithmetic sequence where the first term A1 and a common difference D. So it's recursive because it feeds back on itself, right? Okay. So the nth term of an arithmetic sequence. So if we've identified a sequence as arithmetic and we want to jump straight to a term, right? So given some sequence is arithmetic, then the nth term is given by this guy here, right? So it's going to be the first term plus the n minus 1 times d, where a is the first term and d is the common difference. So if you want to jump to any specific term, you will use this guy for an arithmetic sequence. Okay. And again, if anything isn't clear, if I'm talking too fast or anything like that, just get my attention and we can adjust. Okay. I'm not gonna lie. So I actually kind of like this update. I'm playing this Dokkan battle, Dragon Ball Z Dokkan battle. They got this mode where you can like auto play. So sometimes when I pause, I just start the next round and it just automatically runs from me. It doesn't mean. Okay, let's see. So find the common difference D and the nth term AN of this arithmetic sequence whose fifth term is 15 and whose 20th term is 45. Okay, let me think about this. So things that we can use. We said for arithmetic sequence, the nth term is going to be the first term plus n minus 1 times the common difference, right? Okay, we're asked to find the common difference. We're asked to find the nth term, an, okay? They give us the fifth term and the 20th term, okay? And let me see. So we want the general, so they gave us the fifth. So let's plug in the information that they gave us, right? So when n is 5, the output is 15. Let's capture that. So they're saying that the fifth term is going to be, and did they give us the first term? Does not look like they gave us. So we're going to leave it as A1 because they didn't give us the first term. So n is 5 in this case. So we're going to say plus 5 minus 1. And I think we still need to find the common difference. Okay. Oh, and then that output is 15. Okay. And then the 20th term, so A20 is going to be whatever the first term is plus 20 minus 1 times the common difference. And that output is going to be 45. Okay. So add a page. At this point, we have 2 equations and 2 unknowns, right? So we can actually solve this system of equations. Let me kind of rewrite it really quickly. So we have A1 plus 5 minus 1 times D equals 15. And we have A1 plus 20 minus 1 times D equals 45, okay? Okay. So let's simplify, expand, combine like terms, things of that nature. So I'm just going to kind of continue here. 5 minus 1 is 4. So we have A1 plus 4D equals 15. And we have A1 plus 19D equals 45. Okay. So one technique that we can do, we can solve for A1 in one equation and then plug that into the other. All right. So I think I'm gonna just solve for A1 from equation 1, or from that first equation. So if we subtract 4D on both sides, we'll get A1 equals 15 minus 4D. Okay. So then we can take this A1 and plug it into the second equation. So then we'll get the 15 minus 4D plus 19D equals 45. Okay. I think I'm going to continue working over here. Okay. Notice there's nothing to distribute here. We're not doing multiplication over addition, so we can actually just lose the parentheses and combine like terms. Negative 4D plus 19D is going to give us 15D. So we'll have 15D plus 15 equals 45. Subtract 15 on both sides. 15D equals, what is it, 35, 30, right? Divide both sides by 15, D equals 2, okay? So we found the common difference, and then we need to go back and solve for A1. So we can use any of these steps as long as each step is correct. Honestly, I think I'm gonna use the original equation because that's where we have we're least likely to make mistakes. Like, I'm tempted to use this line here, but I'm like, okay, just in case I made a mistake, I'm going to use the first one. All right. So if we let D be 2, then we get A1 plus 5 minus 1 times 2 equals 15. Okay, combine like terms and simplify. So 4 times 2 is 8. So then A1 equals, what is that, 7? 2 plus 5. Because if you subtract 8 on both sides, you get 7. So we have our common difference. We have our initial term. Let's go back and answer the question. So it says find the common difference. Okay, we found that. And the nth term. Okay, so we need to find an. So then if we put all this together, our an, again, is going to be the first term plus n minus 1 times d. And let me do this. I usually like to do my formulas in like green. Okay. So then our nth term, A1 was 7. We're going to leave the n minus 1, and the common difference is 2. And if we just keep going, simplify, an equals 7 plus 2n minus 2. I distributed the 2. Okay. So then our nth term is going to be 2n plus 5. Okay. Let's copy. Okay. So, and we can verify that this works, right? Because we said that when n is 5, the output should be 15, right? So if n is 5, 5 times 2 is 10, plus 5 is 15, so that one checks out. And then when n is 20, the output should be 45. 20 times 2 is 40, plus 5 is 45. So I can be confident in the 2n plus 5. Okay, so that was algebra. The main thing was getting it set up properly, and then working the algebra until you got all the way down to the expanded form, and make sure to answer the questions. And then once you get your result, we went back and tried to confirm it or check it based on against whatever was given. Okay, let's take a moment. Let me look at the. So let me see. So what the book did, again, they started with the nth term for arithmetic sequence. The nth term was 45 when n was 20. So then they got it down. I think we got that same part. This same something similar for this other point. So then solving the system of equations, right? So let's see. Okay, A1 is 7 and the common difference is 2. So we went through that on how to get that. And then 2n plus 5, as long as n is greater than or equal to 1. Okay. Let me just take a moment to check Zoom, check on you guys in Zoom. It looks like we're kind of rapidly getting through this. Okay. So yeah, we're getting into that stage where the information is getting more and more intimidating for students. So, because of that, that's why, just to kind of create as minimal stress as I could for as many people as I could, that's why I do remote asynchronous, because in the past, like trying to force students to be here, was just a headache. It's a pain. Like we can't just like talk about it. It's like just more of babysitting. I was like, nope, not interested in that. Are they in the next class? But yeah, the thing is, you guys are adults, so if you devise another way to get it done, then something that's a little bit better for you, it's all good. And I just try to make myself available. To answer questions, really, because that's just the nature of it. And it's not really any better in person. If anything, it's worse because then I'm frustrated because I had to show up, and if you had to sit in there and you didn't even have a choice, that's worse in my opinion. Because then I'm exhausted, and then it's just harder to be patient. But that's neither here nor there. Okay. So we looked at, arithmetic sequence where we have a common difference. We saw a formula for finding the nth term, jumping straight to any term in the arithmetic sequence, so on and so on and so on. All right. Okay, I want to try something here. Hopefully I don't scare you guys off. We have the sum of n terms of an arithmetic sequence, okay? I want to see if I can remember how to derive this formula. All right, the sum of the first n terms of an arithmetic sequence, okay. So we're just going to go on. This isn't really anything. This is just trying to put some context as to where this next formula is coming from. So let's see. So say we consider an arithmetic sequence, a finite sum of the sum of the first n terms of an arithmetic sequence, right? So we're going to say the first term plus the second term plus the third term until you get to the nth term, whatever n is, right? Let me think about it. Okay. So if this is arithmetic, right? So then that's going to be the same as, let me see, the first term is just this. But then the second term is what? The first term plus some common difference. Okay. That's fine. And then the third term is going to be that previous one plus a common difference. So that's going to be A1 plus 2D. And then if you keep going, ultimately it's going to be A1 plus n minus 1 times D, right? So when you add up the first n terms of an arithmetic sequence, you get something like this, right? So then let's consider that same sequence. Let me think. Will that help us? If we add, okay. Okay. Let me see, I'm gonna give it a go. So let's consider the same sequence, but we're adding it. And we're gonna reverse the order. So we're gonna say, the anth term first. So that's gonna be A1 plus n minus 1 times D. And then we're gonna say plus, the next one is, the one before that is gonna be A1 plus, I think, n minus 2 times D. And then the one before that is A1 plus n minus 3 times D. And then the last one, all the way until you get back to the first term. So we basically did the same sequence, we just did it in reverse, right? So let me see. Does that help us? I might not have it right set up. Let me think. Hang on. Because if I distribute that, no. Hang on. I feel like I'm moving away from it. Give me just a moment. I'm gonna give myself like 1 minute. Just give me a minute. A1. AN. How did I do it before? I should have thought about it in advance. I'm not. I have something a little bit set up incorrectly. Let me think about it. A1 plus AN. That's going to be okay. Let me put it. Let me scratch this real quick. Give me just a moment. I'm gonna pause this one, and let me try one other thing. If this doesn't work, then I'll let it go. So we have the sum of the first n terms, right? And this is just backstory. You don't need this. It's just me kind of testing something. Till you get to the nth term, right? And then we want to consider the same one, but I think it's in reverse order. So we have AN, the nth term. Let me think. And so this is going to be A1 over here. Mm-hmm. See, this is going to be the n minus first, n minus second, right? So the focus is like these two. If we can show those two in this one, then we'll get the whole thing. Because and you can see a hint to the pattern, right? Because this is just the first plus the last. This is the first plus the last. So the clue is more than likely we can show that this is the first plus the last, right? So the second term, right, is going to be what? The first term plus some common difference. Okay, here it is. I think we got it now. The AN minus first term is going to be the ANth term minus the common difference, right? So if we're working backwards, we're subtracting the common difference. And like, for instance, if we consider the third one, that's going to be the first term plus 2 times the common difference. And if we're working backwards, it's going to be the first one minus 2 times the common difference, right? So then when you say that first line plus the second one, basically what's going to happen is this is going to cancel this is going to cancel this, and they all collapse to A1 plus AN, right? So on the left, we're going to have 2 times SN, and on the right, we're going to have A1 plus AN plus A1 plus AN until you get to A1 plus AN, and that's going to occur n times, right? So long story short, if we consider the sum of the first n terms of arithmetic sequence, it's going to be 2 times. We're going to have n times A1 plus AN, and divide both sides by 2. You get n times A1 plus AN over 2. Okay, I think that's it. That was an adventure. I know it was a little bit, kind of bad, but I just wanted to see if I can remember, because I hadn't looked at this in at least a year. But I wanted, because I knew it was something kind of like that where the terms would cancel out. You don't need to know this. I just wanted to give you some context for where this comes from, right? So again, you don't have to know all of that. And we were kind of on our way here, but there was the way we wrote it, we were kind of not seeing it. So we had to go back and kind of rewrite it a different way. Okay. So if you consider the sum of the first n terms of an arithmetic sequence, it collapses down to this guy here. Okay. And there's another one that comes up a little bit later. We're gonna, just give it a go. It might pop up. So that brings us to this. So let A1, let this be the first n terms of an arithmetic sequence of the common difference D. Then the sum of these terms is given by this guy here, which is what we just got. N times A1 plus AN over 2, right? So we saw where those different components came. Where the nth term is going to be A1 plus n minus 1 times D. Okay. Yeah, I just had to change the form. So, we just wanted to give a little bit of context on where this guy came from. Okay. So find the sum of the arithmetic sequence of numbers. Okay. All right. So let's kind of write what we just came across. So we know that the nth term of an arithmetic sequence is A1 plus n minus 1 times D. Also, the sum of the first n terms of an arithmetic sequence is going to be n times A1 plus AN over 2. Okay. So in order for us to find, so here, let's fill in the different components, right? let's see, we'll identify n in just a moment, but it looks like our first term is 1, okay? So then for the nth term, we need to find the common difference, okay? So if it's arithmetic, notice to go from 1 to 4, we're adding what? 3 plus 3, so on and so on and so on, right? So it looks like our common difference is 3. We're adding 3 each time. Let me see. Is there a better way to find that? We got the first. We don't know that, so we're trying to find that. Let me see. How many terms? Okay. So we have our nth term is 25. We can solve for n, right? So let's start here. If we say that the nth term is 8, the first term plus n minus 1 times the common difference, right? Let's plug in. We have a lot of this stuff. So our nth term is going to be 25. A1 is 1. We don't know n. We're trying to solve for that, and the common difference is 3. At this point, we have one equation, one unknown, so we can solve for n, okay? So if we distribute the 3, we get 25 equals, what's that, 1 plus 3n minus 3. So that's going to be a negative 2. So then if you add 2, you get 27. So we get 3n equals 27. Divide both sides by 3, n equals what, 9. So what we're saying is that 25 is the 9th term in this sequence, right? So we solved for n. So then now we want to go back and find the sum of the first 9 terms. That's going to be our n, which is 9. The first term is 1. The 9th term is 25. And whatever that is divided by 2. So 1 plus 25 is 26. 26 divided by 2 is 13, times 9 is 90, plus 27. What is that? 117. Okay. I know it's a little bit all over the place. I feel like, let's just undo that. Can we just delete? I kind of want to try some more. Okay. I feel like there should be questions. I mean, you know, it's okay. All right. Let's see. So we got 117. And so here's a type version of what we experienced, right? So our arithmetic sequence where the first term is 1, the common difference is 3. First, find the number of terms, right? So we started with the nth term of arithmetic sequence. We plugged in our nth term, and we plugged in our common difference, and we solved for n, and n was 9, right? So we had the same experience. We solved for n. Then we just plugged in the different components into our finite sum. A1, an, and n, and you get the 117. Okay. Oh, that was it. Oh, we made it to the end of this one. That's not common. Okay. So I think what I will do with the time remaining, we got a solid 15 minutes. I think I'm just going to go ahead and start working on the homework. That'll give us more opportunities. Let's see. Okay, let me get the student. I'm going to stop the screen share for right now. The student. Okay. And then let me go ahead and log into Pearson and let's pull that up. Right there, gentlemen. Is there another one? Let's just go like this. Pearson. Allow. Sign in. That's fine. Allow. Come on. All right, so this is College Algebra 2. All right, and this is what, week 10? Yeah, arithmetic sequence and partial sums. Okay. Let me see how many questions. It's like 19 questions. Okay. That's that. And let me share my screen. Okay. All right. So in this first example, it says determine if the given sequence is an arithmetic sequence. If it is, find the common difference, right? So arithmetic means that we're adding the same thing each time. So to go from 5 to 7, we add 2. Yeah, we're adding 2 each time. So we're going to say yes and go on to the next question. Okay. The common difference is 2. Let's turn this off. Come on. And we want to put in 2 right there. Determine if the given sequence is arithmetic. Tempted to make it a little bit bigger. Hopefully you can see it okay. So notice to go from 6 to -9, we're adding what? -15? No, we're not adding the same thing each time here. Because to go from 6 to -9, I think we're adding -15. But if you add another -15, you do not get to +12. So is this sequence arithmetic? We're going to say no. Come on. Okay. Is this one arithmetic? Let me see. So if that was 5, 0.9 plus 0.2 is 0.11. We're subtracting 0.11. So 3726. So 1.1. Negative 1.1. We're basically adding negative 1.1 at each step. Okay. Determine whether the given sequence is arithmetic. Okay. So here, with this one, you might want to look at like about 3 or 4, maybe the first 5 terms to confirm. So for instance, when n is 1, the output is 5. When n is 2, 3 times 2 is 6 plus 2 is 8. So the output is 8. When n is 3, 9 plus 2 is 11. Let's do a few more. When n is 4, 12 plus 2 is 14. Let's do one more. When n is 5, 15 plus 2 is 17. Are we adding the same thing each time? First, we added 3, 3, 3, 3. Yes. Right? So it looks like we're adding 3 each time. So the first term, A1, is just going to be 5. So the sequence is arithmetic, and the common difference is 3. Okay. Hopefully that's okay. Hopefully that's clear. Yeah, because we're kind of breezing through this as well. I mean, we'll see about what we do on Wednesday. Find an expression for the nth term of the following sequence. We got a solid 10 minutes. The nth term, right? Okay. So we just said that the nth term of an arithmetic sequence is going to be a sub 1 plus n minus 1 times d, right? So we have our first term, which is 6. So we can replace a1 with 6. Common difference, right? 6 plus 3 is 9, plus 3 is 12, right? It looks like we're adding 3 each time. So our common difference is 3. And then basically, if we distribute the 3 and simplify, we're going to have 3n, and it's going to be what? 6 minus 3 is a plus 3. Okay. So it should be 3n plus 3. So for instance, the first one is 6, the second one, so yada yada. You can confirm that these work for each term. So if we go with it, okay. Man, we've almost done the homework here as well. Use the formula for AN to find the general term of the arithmetic sequence below. So maybe what I might do, I might just go ahead and get ahead. Like maybe if we finish, depending on where we get here with this today, I might go ahead and do 6.3 on Wednesday, and then we can take next week to start preparing for the exam, like reviewing. We can actually review before the exam, right? If we get ahead or whatever. I use the formula for AN to find the general term of arithmetic sequence below. Okay, what are we adding each time? Okay, we might need our calculator for this one. This one. Okay. Let's reload and refresh. Okay. So for instance, if we do 39 over 4 minus 9, I'm gonna hit math as a fraction. We get, so it looks like we're adding 3 over 4 each time. So if we say 9 plus 3 over 4 as a fraction, we should get 39 over 4. And then if we say plus 3 over 4 as a fraction, 21, and I'm just go ahead and do the next one. Plus, actually, I could just recall what I typed. Second enter, we should get 45 over 4, right? So we're adding 3/4 each time. We should write this out. Let me think. So the first term is the 9 plus n minus 1 times d. Yeah, I'm just being lazy. So if we write it out here. So the nth term of an arithmetic sequence is going to be given by a1 plus n minus 1 times d. Okay. So then our nth term is going to be 9 plus n minus 1 times 3/4. Okay. If we distribute the 3/4, we're going to get 9 plus 3/4 n minus 3/4. Whatever 9 minus 3/4 is. 8 1/4. 9, come on. 9 minus 3 over 4 as a fraction, 33 over 4. Okay. 3 over 4 times n plus 33 over 4. So what is that, like 8 1/4? 32, yeah, 33 over 4. Okay. So that's our nth term. 3/4 n plus 33 over 4. Okay. 3/4 n plus, yeah, c, right? And then we can confirm that it works before we submit it. When n is 1, we should get 9. That's going to be 36 over 4, which is 9. When n is 2, 6, so it's going to be 39 over 4. When n is 3, is 9, 42 over 4, which becomes 21 over 2. Yeah, right? So that looks like it's working out. I'm just going to go ahead and submit that one. We'll do one more and we'll call it a day. I find an expression for the nth term of the following arithmetic sequence. Okay, let me take some notes here. So I'll get a copy of it. Okay. Gonna go to about here. All right. And let's take that. Let's drop it here. Oh, we're out of space. Let me add a page. Okay. All right. Okay. We want the nth term. Okay. So if it's arithmetic, then it's a good idea. We might be using, it's going to be what? The first term plus n minus 1 times the common difference. Okay. So we need to find the common difference. Let's see. -2/7. It looks like we're adding, it looks like our common difference is -2/7. It looks like we're adding -2/7 at each step. Okay. So our nth term is going to take on the form -5/7 plus n minus 1 times -2/7. Okay, we just need to simplify that. Let's work over here. Okay, so our nth term is going to be, we still have this -5/7. If we distribute, we're going to get -2/7 times n plus 2/7. Okay, combine like terms and simplify. 2/7n, -5 plus 2 is what? -3, so -3/7. So that should be the form of the nth term, right? And we can confirm it, make sure that it works in like for each step, right? Oh, not, you could have told me that, you know, it wasn't showing. I don't know how long that had been going on. Okay. All right, so when n is 1, -5/7. When n is 2, 4 plus 3 is 7/7, which is -1. When n is 3, 6 plus 3 is -9, okay? So on and so on and so on, all right? So this is working out. Okay. All right. So we got -2/7n minus 3/7. Right here, okay. -2/7n minus 3/7. Okay. All right. Are there any burning questions? Let me go ahead and make a copy of our notes available for you guys. Come on. This is the fall, College Algebra 2, into the note section, updated daily. Yep, week 10. It's in the box. Okay, so when this bar finishes loading, you'll get a copy of anything that you saw me writing. If there aren't any burning questions, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. Peace.